So in this video I'll be showing you how we can solve quadratic or polynomial inequalities. Now before we get started, what I'm going to do is I'm going to talk you through the steps that we go about doing this. Now if you have one of the more modern scientific calculators, there may be a feature where you can do this without doing any of these steps or doing any form of sketching. So all you need to do is just know how to use your calculator, type in the right values, press your equal button, and it will give you the answer. However, if you don't have that sort of capability or that type of calculator that does this, what I'm going to do is talk you through how, and hopefully it makes a bit of sense in terms of these. Now before we get started, what I'm going to do is go through the steps, in which I'd recommend that you write down these steps before we go through some examples. So this is not the only way of doing it, this is just a recommended way, just to make some sense of it for going forward. So the first thing I'd recommend that you do is always check to make sure that the equation is equal to 0. So just like when you're solving a quadratic or a polynomial, the general step is make it equal to 0. Once you've done that, what I'd recommend that you do is sketch the curve, so recognizing the shape, and also label the x-intercepts. Now the first part of the question might be where you are solving the equation, in which you may already have the roots. So all you'd need to do is first of all start with your x-axis, mark down the roots, then draw your y-axis, join the points up with the correct shape, and away you go. And if you're not too sure about how to sketch the curves or quadratics or polynomials, I have made a video that shows you just that. Then the next thing I'd probably recommend you do is try and translate what the inequality equation's actually doing. So if you've made it equal to 0, with the 0 being on the right hand side, then the equation refers to the curve. The inequality, now if it's less than, it means below, and if it's more than or equal to, it means above, and the 0 represents the x-axis. And then on your sketch, highlight the parts of the curve that satisfy step 3, and then the final step is then using the graph, write down the range of values of x that satisfy the inequality. Now, as I mentioned, rewriting the equation is something that a lot of students might find a little bit easier to understand. So in this, if you find that your 0 is on the left hand side, more often than not, students tend to prefer things on the right hand side. So typically when you're solving an equation, you usually have, let's say, like 3x plus 6 equals 10 rather than 10 equals 3x plus 6. It's just more aesthetically pleasing for the equal sign to be whatever it equals to be on the right hand side. Now if you are one of those type of people that would prefer that, then the key thing to remember is if you flip the 0 from the left hand side to the right hand side, you also need to flip the inequality. So for example, if we had 0 is less than x squared plus 3x minus 8, then to flip that, it would turn into x squared plus 3x minus 8 is greater than 0. And if we had a polynomial, in this case a cubic equation, and we had 0 is greater or equal to x cubed plus 3x squared minus 5x plus 10, then that would turn into 3x squared plus 3x squared minus 5x plus 10 is less or equal to 0. So note that none of the terms in the equation changes its sign. The only thing that changes is the inequality sign. So if we start off with solving a quadratic inequality, so what I'm going to do is, let's say we were asked to solve. Now just to speed up the process, what I'm going to do is I'm going to write the inequality where it's already been factorized, and let's say this is going to be greater than 0. So the first thing we need to do is obviously make sure that it is equal to 0. Well, the inequality is equal to 0, which it is. And then what I now need to do is sketch this graph. So from this, I know that my roots to this particular question is going to be minus 3 and positive 5. So if I start by drawing my inequality, I also know that this is going to be a U-shape, a positive parabola. And so if I sketch my two roots of minus 3 and 5, and I draw my not so neat parabola, and I know that my y-axis is going to be somewhere here. Now for this, the y-axis and the graph isn't really important, however it's useful just to have a bit of good practice that you're able to do this. So all I've done there is I've sketched this inequality. Now translating this equation, what I've got is that this, if I just get a different colour pen, and so from the steps, what I mean by in terms of translating this equation, this is where what the question is asking me is where the curve is above the x-axis. So translating this question here, this is what I get. I get where the curve is above the x-axis. Now, for the region of where I'm going to mark this on my graph, the values of where the curve is above the x-axis is there and there. Now, looking at the diagram to represent the values of where the curve is above the x-axis, well, this is where x has got to be less than -3 because it's going in the left-hand direction. And this here represents where x is greater than 5. So note that it's going in this direction of where it's going to be greater than 0, or greater than the x-axis, and going in this direction is where it's going to be above the x-axis. So the answer to this particular question is where x is less than -3 and x is greater than 3. Now likewise, if we had the question where, if I change the colour just hopefully make this a little bit more sense. So if I had x plus 3, x minus 5 was less than 0, then this is basically translated is where the curve is below the x-axis. Now where the curve is below the x-axis is this part here. Now, as you can recognise that where I've shaded this in green is one single line, what's one single part of that curve. Now, how we represent this, I'm looking for where x is got to be between those two numbers. Now, how I'd represent that in an inequality would be where -3, where x is between -3 and 5, exclusive of those numbers. Because looking back at the original equation, it's where it's greater than 0, it's where it's above the x-axis, not on the x-axis. So if I was to go on to have a look at another equation, so this time let's say that we had an equation that didn't factorise, and from that let's try and speed up the deletion of all of that. So let's say I was asked to solve an equation that doesn't actually factorise. So solve, let's go for x squared minus 4x minus, let's go for 7 is less or equal to 0. Now this translated, before I even go on to sketch it, means where the curve is below or on the x-axis. So translating this question into words, I'm looking for the region where the curve is below or on, and the reason why it's on is because it can equal that, and then the 0 represents the x-axis. Now if I was to go on to solve this equation, in which I would probably have to use the quadratic formula if it doesn't factorise, but I'm hoping that it doesn't, we get the answer of, and thankfully we do, so solving the equation, which we know is going to be a U-shape. So solving x squared minus 4x minus 7 equals 0, I get x equals 2 plus root 11 and 2 minus root 11. So from this what we get is, now both these two values are going to be negative, one's positive, sorry. So this is going to be round, so this is my positive value, this is my negative value. So if I then go on to draw a sketch, I could say here is 2 minus root 11, and here is 2 plus root 11. Now I'll be honest, the y-axis, the accuracy of this doesn't really need to be true. So all I'm going to do here is draw my U-shape of this parabola, and looking at this, what I'm looking for is I'm looking for where the curve is below the x-axis. So what I'm looking for is this region here, and as you can see, this is one single part of the equation of the curve. So how I'm going to write this is that x needs to be between 2 minus root 11 and 2 plus root 11 inclusive of those numbers. So that there would be my final answer. Now, if I had the question of the opposite of that, so let's say I had x squared minus 4x minus 7 is greater or equal to 0, then I'm looking for where the curve is above the x-axis. Then I'd be looking for these two regions here. And as you can see, you've got two separate parts of the line. So this here would represent x is less than 2 minus root 11. And this would represent x is greater than 2 plus root 11. Now, one of the advantages of making 0 on the right hand side is that the direction of where you've shaded would be the direction of your inequality. So looking at this, you can see that it's going in that direction, which is where the inequality is going in that direction. And for this here, the inequality is going that direction because those values are going towards the right. Now let's say we had a negative parabola. So let's just get to a point where I just change the colour of pen. So let's say we were asked to solve minus x squared plus 4x plus 6 is less than 0. So here we're going to end up with an N shape or a negative parabola. And so if we then go on to solve minus x squared plus 4x plus 6 equals 0, then what we get are our solutions as being is 2 plus root 10 and 2 minus root 10. And that would be our values of x for where it equals 0. So drawing my x-axis, I know that this here is going to be my smaller value. So if I put this more on the left, in which I get that, and the other value is going to be on the right hand side. And again, I'm looking for an N shape or a negative parabola. So going from the description of what the question's actually asking me, it's saying where the curve is below the x-axis. So going back to the diagram, where I'm looking for this region here and this region here. And as you can see, there are two separate parts, which means I'm going to end up with two separate inequalities. So the answer to this particular question is going to be where x is less than 2 minus root 10 or x is greater than 2 plus root 10. So as you can see, whether it's a positive parabola or a negative parabola, drawing the sketch does happen and is one of the things where, if on the older papers, mark schemes do encourage the use of a diagram. And so, like I said, it doesn't need to be a full sketch of a quadratic graph, but hopefully by showing you how we can use the x-axis and just marking where the roots are, it makes it easier for us to solve the inequality. So if we have a look at solving polynomials, in this case what we'll do is we'll have a look at a cubic graph. So let's say we were asked to solve, and again I'm going to kind of take a few shortcuts here. Let's say we had x minus 5, x plus 1 and x minus 2, let's say, is greater than 0. Now this is obviously going to produce a positive x cubed, in which our graph is going to look something that looks like that. So it's always important to recognise the sort of shape of the graph just to make your head round in terms of the roots. So from this, as we go on to solve this for where it equals 0, so before we do that, let's translate what this actually means. So this means where the curve is above the x-axis. So if I go on to solve this equation, the roots are going to be at positive 5, minus 1 and at positive 2. So if I start by drawing my x-axis, so for example here is my x-axis, my smallest root is minus 1, which I just label there minus 1, the second smallest is 2 and the largest is at 5. And again, recognizing the shape of what that cubic graph is going to look like, I can then do a little sketch of what that's going to be. So what it's going to be is it's going to look something like that. And again, apologies for that, should really go through the point, but we can pretend that it does. Right, so going back to what this means, I'm looking for where the curve is above the x-axis. So if I just highlight where this curve is above the x-axis, well, it's above here and it's above on this region here. So with a cubic graph, you're going to end up with a few more solutions, and as you can see, I'm looking for two different answers that this could be. So how we go about answering this? Well, first things first, let's do the left hand side, so this here. So what that part there represents is where x is going to be less than -1, and because this is a region, so if I just quickly highlight all of that, so what I'm looking for is this part here and that part in the middle there. And so going on from that, this part here is going to be represented with 2x and 5. So x is going to be between 2 and 5, exclusive of those two numbers, and there are our solutions. Now, if I was asked to do the reverse of that, so let's say I was asked to solve x minus 5, x plus 1, x minus 2 is less than 0, and again the roots for this are at 5, -1 and at 2. And again, just doing that sketch again, so I've got -1, 2 and 5. Let's see if I've got a better chance of sketching this one. So what I've got is I've got something that looks closely similar to that. So here what I'm looking for where the curve is below the x-axis. So again, shading that region there, I'm looking for this part here and this part here. So I'm looking for that range there and this part here of that x-axis. So for that first part, so for this here, x has got to be between -1 and 2, exclusive of those numbers. Now again, if I just put that to less or equal to, then I can then put a less or equal to here, and this part here is going to be where x is going to be greater or equal to 5. And there are your two possible answers. Now if I was to move on to another question, so let's move on to possibly something that does not factorize. So in this next example, let's go for trying to solve, and again, just to save time, I'm going to pre-factorize this particular equation. So let's say we had x plus 4, x squared minus 5x minus 10 is less or equal to 0. So going on from this, what we want to do first, so is recognizing the shape. So we're going to end up with a cubic shape where it goes down first and then loops over, in which the first we need to do is find the roots. So the roots at this particular equation is going to be at -4, and then this becomes, we have to use a quadratic formula to solve this. So this becomes 5 plus or minus root 65 over 2, which as a decimal equivalent is 6.53 and minus 1.53. So if I then go about drawing my x-axis, here is my -4, here is going to be 5 minus root 65 over 2, and here is going to be 5 plus root 65 over 2. Now again, this is just a sketch. The fact that we've labelled these three numbers in in ascending order should be fine. So the next thing we then need to do is just make an attempt to join these points up, and let's definitely do that again. I'm not happy with that. That's a little bit better. So again, what translating this, we've got that the curve is below the x-axis. So looking at my graph here, or my sketch, I'm looking for this region here and this region here, which is where the curve is below the x-axis. And if you're not too sure what I'm talking about, let me just get a different colour pen. And I'm looking for that region there and this region here. So first of all, writing this as an inequality range, we've got where it's minus 4x and 5 minus root 65 over 2. And for this region here, it's going to be where x is greater than 5 plus root 65 over 2. Now, a common question that we usually get asked is, if I wrote the decimal equivalent of those values, would I still get the mark? Well, it's very good practice at this level to try and use exact values where possible. So I'd encourage you to use your surds rather than use decimal equivalents. But like I said, if you were, it was just a case of looking at the values. As long as you are writing this as its surd form when you are going on to solving the quadratic of x squared minus 5x minus 10, and you wrote down that the equivalents of those would be those two decimal places, then it should be fine. But try and get in the practice of using the exact values and using surds to go on from there. So just to go over this again, so the answer you should write for the answers of this particular question would be, so the solution is going to be where x, is going to be where x is inclusive of minus 4 and 5 minus root 65 over 2, or where x is greater than 5 plus root 65 over 2. And so whether you've got a positive cubic shape or a negative cubic shape, it's definitely worth going through those steps of solving the polynomial, whether it be quadratic, cubic, finding out the roots, drawing the x-axis, mark down your roots, recognizing the graph shape, and then from your curve deciding what the inequality is going to be. So hopefully with the examples I've shown, hopefully it makes a little bit of sense. And if you have any questions, feel free to drop me a tweet or an email.